Assalamualaikum warahmatullahi wabarakatuh and very good morning everyone. So for today we're going to practice for chapter 3. So what we are going to do today, I'm giving you an example of a question and we try to see how we can solve the question. Alright, so let's go directly to the question. Alright, let's say you are given this question. So let's read the question together. An elementary gas phase reaction to produce ammonia is executed by reacting nitrogen and hydrogen gases. Okay, it is carried out isothermally in a plug flow reactor at operating condition of 500 Kelvin and 6 atm. An equimolar reactant enters the reactor with each molar flow rate of 2.5 mole per minute. Given the specific reaction rate K is 0.1 decimeter cube per minute times mole cube at 400 Kelvin. So this is K at 400 Kelvin. With activation energy, E is equals to 85 kilojoule per mole. Okay, there are 3 questions. The first one is to construct a stoichiometry table and then express concentration of each species as a function of conversion. That means they are not asking us to give you one value. Instead, they ask us to give some equations because we have to express concentration as a function of conversion. We are expecting there will be several equation unsolved equation where you will use conversion inside the equation. Okay, then B, compute the concentration of each species. So just now they asked us to express the concentration as a function of conversion. So B, you have to solve. You have to find the value of the concentration where the limiting reactant is only 10% remain. So from these sentences, you actually can know what is the X, the conversion in the reactor. And this one, 8 marks. Okay, and then C, if the reactor were replaced by CSTR, just now was another reactor, plug flow reactor. This time CSTR. What would be the required CSTR volume in meter cube to achieve conversion mentioned in part B? Right, so let's see the solution. So what do we do? Now, the question asks us first to construct a stoichiometric table and express concentration of each species as a function of conversion. So if you remember, when we construct a stoichiometric table, the most right part of the table is actually the concentration expression. So it's okay, we will end it up with that. But now, first step, what do? We have a paragraph telling us a lot of information. What do? Is first step, we need to extract information. So let's go back to the paragraph. How do you extract information? Let's go sentence by sentence because all are important. First, an elementary. So this is one information. And then it's a gas. Another information. Elementary gas phase reaction to produce ammonia, which means ammonia here is the product. So we know already the ammonia is the product. But what are the reactant? Is executed by reacting nitrogen and hydrogen. Okay, so we have 2 reactants, nitrogen and hydrogen, and we have one product, which is ammonia. So as a chemical engineering student, you should know how to write the chemical formula for nitrogen, hydrogen, and ammonia, and also how to write the reaction and balancing the reaction equation. All right, what are other information? It is carried out isothermally. So isothermally means temperature in is equal to temperature out. Temperature initial is equal to temperature final. No changes of temperature. In a plug flow reactor. Plug flow reactor. This is important if you want to find the volume of the reactor. At operating condition of 500 Kelvin. Okay, so the temperature of the reactor is 500 Kelvin and 6 atm. The pressure is 6 atm. All right, no information given whether it's isobaric or is there any pressure changes, so we can assume isobaric. And equimolar reactants. So equimolar reactants means since we have two reactants, nitrogen and hydrogen, we don't know which one is A, we don't know which one is B, but when it says that equimolar reactants, then that means that it's, if we find the, apa namanya tu? The Y, which is the fraction, okay, mole fraction. So YA naught should be equals to YB naught, and that is equals to 0.5 because it's equimolar. Or we can say that FA naught is equals to FB naught. And how much is the F? So we see here an equimolar reactants enter the reactor with each molar flow rate of 2.5 mole per minute. So FA naught is equals to FB naught is equals to 2.5. Okay. Given the specific reaction rate, K is 0.1, but that one is K at 400 Kelvin, not K at our condition. What is our condition? Our condition is 500 K. This one K at 400. That means you need to find K at our condition. And then we have that information where activation energy is equals to 85 kilojoule per mole. So these are the information that we got from the paragraph. So now I help to recap back what it mentioned. So we extract the information. It says that the reaction involved reaction between nitrogen and hydrogen to get ammonia. Okay, you can see clearer like this, I think. All right, so nitrogen plus hydrogen to get ammonia. Now, what do? We write the chemical equation and balance it. So this is nitrogen, react with hydrogen to get ammonia. You should know how to write the chemical formula. So you balance the chemical equation. We got nitrogen plus 3 hydrogen to get 2 ammonia. Is this the right way to write the chemical equation? Yeah, it's balanced, but to proceed afterwards, we might need to know which one is A, which one is B. Okay, before we proceed, let's see what more of the information given just now. Okay, reactor, type of reactor and condition. Okay, reactor type, PFR, temperature 500 K, pressure 6 atm. And then we have equimolar reactants. So equimolar reactants, so Fa naught is equals to Fb naught equals to 2.5 mole per minute. Which one is A, which one is B, we don't know yet. Additionally, it says that at 400 Kelvin, this is the value of K, which is 0.1. EA is 85 kilojoule per mole. EA we can use, it's going to be the same, even though it's at different temperature, but we're going to need to find our K because our temperature is 100 Kelvin. Okay, and then what else we have? Okay, from the sentences, it mentioned that it is an elementary reaction. So what happens if it is elementary reaction? Then it will affect the reaction law. The RA minus RB will be affected. Gas phase reaction, then what happened? It will affect the stoichiometric table, the formula in the stoichiometric table. It's isothermal, then we can write that T is equals to T naught. So it will simplify your stoichiometric table. An assumption isobaric also. So P is equals to P naught. It will simplify your stoichiometric table. Okay, before we proceed, we need to identify which is limiting reactant. Then only we know which is A, which is B. Okay, so what do? We know that the information mentioned that the inlet is equimolar reactant. So we assume 3 mole of nitrogen react with 3 mole of hydrogen. Why did I choose 3? Because the formula here is 1 nitrogen react with 3 hydrogen. So to ease the equation, I'm going to choose the stoichiometric available here, which is 3. Okay. So based on the equation, we have 1 nitrogen react with 3 hydrogen to get 2 ammonia. So initially, if it's equimolar, we assume that it's not 2.5 because hard to calculate. So I'll just assume it's 3. This is for assumption purpose, just to find limiting reactant. So initially, let's say 3 nitrogen react with 3 hydrogen. So 1 nitrogen react with 3 hydrogen. So reaction, how much reacted? 1 mole of nitrogen will react with 3 mole of hydrogen. So finally, how much concentration left? How much more left? Nitrogen, since initially we have 3, 1 reacted, we get 2 mole unreacted. Hydrogen, 3 mole, react with 3 mole because 1 react with 3. So all end, complete reaction. So since hydrogen finished first before nitrogen, we can say that hydrogen is the limiting reactant. Okay, we have concluded the limiting reactant. So you can write back the equation. Instead of nitrogen plus hydrogen got ammonia, you change to hydrogen plus nitrogen to get ammonia. So this one can be translated into alphabet. We get 3A plus B to get 2C. What is the effect? When we write this one, remember back, the reaction is elementary reaction. And we know elementary reaction, we can write Rate law for all reactants and product. Okay, we know that the equation is like this, 3A plus 1B. So if we write the Rate law, we have to start with the Rate law of limiting reactant A, which is hydrogen. So since it is a reactant, it should be minus Ra is equals to K. Since it's elementary, we have to write Ca to the power of the stoichiometric constant, which is 3, times Cb to the power of the stoichiometric constant, which is 1. So here we got the rate law for hydrogen. How about the rate law of others? Okay, how do we find? Then we use relative rate of equation. This is the relative rate of equation, where here we can notice that for reactant, it will be minus rate law, we have A and B as reactant over the stoichiometric. So here we have 3A react with 1B to get 2C. So 3 for A, 1 for B, 2 to C, and C is product, so it's positive. So this is the equation, the relative reaction rate equation. So since we know already that minus rate law is equals to minus RA, which is the rate law for hydrogen is equals to KCa3Cb, then we can find for nitrogen, which is B. So we know that we take part of this, minus Ra over 3 is equals to, this is equals to minus Rb over 1. Then we can rearrange, transfer 1 to the other side. So we got minus Rb is equals to 1 over 3 times minus Ra. We know that minus Ra, here minus Ra is equals to KCa3Cb. Then we directly put, so we got minus Rb is equals to 1 per 3 KCa3Cb. Okay, so settle for rate law for nitrogen. If in case they ask for it, then you already prepared with the answer. Then rate law for ammonia, which is the product. So from the relative rate of equation, we take this part and we take this part, which is a product. So we have minus Ra over 3 is equals to Rc over 2, okay? So we rearrange, transfer 2 to the other side. So we got Rc, this time is positive, is equals to 2 over 3 times minus Ra. We know already minus Ra is equals to KCa3Cb. Then we put into the equation, we got Rc is equals to 2 per 3 KCa3Cb. Finish, settle for rate law. Back to the equation, okay? Back to the equation, we already translated everything into some useful information. Now the equation said construct stoichiometric table and express concentration of reactant and products as a function of conversion. So this is our target. Okay. Before we proceed, what do we do before we construct the table? We need to let the stoichiometric constant for A, the limiting reactant, is equals to 1. So at first the equation was 3A plus B to get 2C, or 3H2 plus nitrogen to get 2 ammonia. Then we divided everything with 3, we got this new equation. 1 hydrogen react with 1 per 3 nitrogen to get 2 per 3 ammonia. We change into alphabet, A plus 1 per 3 B got 2 per 3 C. Okay, this is what we do before we construct the stoichiometric table. Okay. Then we construct the stoichiometric table. So ensure that you know that it's a gas phase. We prepare the species. We have hydrogen as the limiting reactant should be the first. And we got nitrogen and then the product, which is ammonia. Put in the symbol A, B, C, put the initial value. So now we don't put any value yet. We just copy paste all the information that should be there in the stoichiometric table. So initially, A, there should be how many mole per minute, the flow rate. So that will be FA naught. And then mole per minute. Mole per minute. How about B? So instead of writing FB naught, remember, in the standard stoichiometric table, we're going to write FB naught is equals to Fn naught times theta B. So theta B here, later on, we have to confirm lah how much is the value. For now, we just construct without putting any value. For FC naught, so FC naught is equals to FA naught theta C. And how about the changes? So this one you know lah, FB naught is equals to this one, FA naught B. So how about FC naught? FC naught is equals to FA naught theta C. So this one theta B, this one theta C. So how much is the changes? So the changes for A, since it's a limiting reactant, it will be minus Fa naught, minus because it's a reactant lah, minus Fa naught times X, the conversion. How about nitrogen? It will be minus the stoichiometric here. So how do we get this value? Simply we take from here lah, 1 per 3 times Fa naught X. How about the changes for product? So it's product, so it's positive. How about the stoichiometry? Then we simply take from here 2 per 3. So put 2 per 3 times Fa naught X. Okay, we settle for changes. How about the remaining? The remaining is simply initial plus changes. So initially, we have Fa naught, so Fa naught plus changes. So changes here is minus Fa naught X. So Fa is equals to Fa naught minus Fa naught X. Okay, we do the same for the others. Fb is equals to Fa naught theta B, Fa naught theta B, minus 1 per 3 Fa naught X, minus 1 per 3 Fa naught X. Similarly for C, we got Fc is equals to Fa naught theta C, Fa naught theta C, plus, since it's a product, 2 per 3 Fa naught X. Settle with the remaining. But the question asks us to express the concentration. We need to finalize with the concentration. We don't need to solve it because we can write it as a function of conversion. Okay, we change this into concentration. You already know, I have teach this part. It's just that we know the information mentioned in the paragraph that the reaction is isothermal and also isobaric. So isothermal and isobaric, because of that, actually there's supposed to be T over T naught, P naught over P here. We can actually exclude that since it's equals to 1. So we have simplified the equation. We just simply write as Ca is equals to Ca naught 1 minus X per 1 plus epsilon X. We do the same for Cb. Cb is equals to Ca naught theta B minus 1 over 3x, okay, minus 1 over 3x over 1 plus epsilon x. This 1 plus epsilon x appear because it is a gas phase. If it is liquid phase, then you won't have the denominator here lah. And then for product, Cc, concentration of C after certain time is equals to Ca naught theta C plus 2 per 3 x over 1 plus epsilon x. All right, we have solved question 2 actually, question A actually. However, it will be great if we directly solve some of the information inside. Okay, what are the information that we didn't put in yet? So we don't write yet our theta B. So theta B is equals to mole fraction of B naught initially over mole fraction of A naught. So initially we have equal molar. So if total is 1, then mole fraction will be 0.5. For B, 0.5 for A. So 0.5 divided by 0.5, it will be equals to 1. So we got theta B. That means we can replace for this part lah. Also for this part, because later on we have to solve the concentration. So this one is important actually. This column is important. And then theta C, because we have theta C here. Theta C is equals to what? Theta C equals to mole fraction of C initially over mole fraction of A initially. In the paragraph, it didn't mention that the product are there initially. So y C naught automatically will become 0, 0 divided by everything we got 0. Okay. What else we don't know here? We don't know what is epsilon. The rest we know. Okay. X we know in B actually. So epsilon is what? Epsilon, the equation is epsilon is equals to y and not delta. So delta is what? Delta is equals to the difference in the stoichiometric constant. So it will be product minus reactant. Okay, look back at the equation here. So product is 2 per 3, reactant we have 1 per 3 and also 1. So 2 per 3 minus reactant is 1 per 3 plus 1. So in bracket lah. Then we got the result minus 2 per 3. That is delta only. So we have to find epsilon. So epsilon is equals to y and not delta, which is equals to 0.5 times minus 2 per 3. We got epsilon is minus 1 per 3. And then what else we don't know? We don't know what is C and naught. Okay? What is C and naught? We didn't complete yet actually. Others, the rest, we have completed it. Okay, so C and naught. Since the reaction involves gas, so C and naught we have to calculate. And we have to calculate it using ideal gas law. Why? Because it's a gas. So from ideal gas law, C and naught is equals to Y A naught P over RT. We know already Y and naught is equals to 0.5. P was given 6 atm. T was given 500 K. And choose the right R. Okay, based on the unit. It must have atm, it must have Kelvin. So here that will be 0.082. So we got C and naught is equals to 0.0731. Then put all of this information. Then actually we have finalized our table by ensuring that the concentration column represents concentration expressed in the form of conversion only. Others are already in numbers. Now, actually, we have completed question A, not previously, okay? So we have completed question A, okay, done. Let's go to question B. Question B, compute the concentration of each species. Find what is Ca, what is Cb, what is Cc. That's what they ask. When limiting reactant is only 10% remain, which means X is equals to 0.9. Why? Because 10% reacted, 90% remained. 10% remain, 90% reacted. Okay? So we got from the question that X is equals to 0.9. This concentration equation have only one unknown, which is X. So we can simply find Ca, Cb, and Cc by putting the value of X, which is 0.9. Okay, we do for all. First, we do for A, Ca from the equation is equals to 0.0731 times 1 minus X over 1 minus 0.3 X. Put everything, put the 0.9 into X, we got Ca is equals to 0.01044 mole per decimeter cube. Ensure that you write the correct unit. Then we have Cb, based on the equation, equals to 0.0731 times 1 minus 1 per 3x over 1 minus 0.3x. Actually, if you notice, the top and the bottom here, the numerator and denominator here is actually equal. 1 per 3 is actually equals to 0.3. Actually, you can neglect this because it's equals to 1. That is why in the end you get 0.0731 mole per decimeter cube. And finally, for Cc, put back the equation is equals to 0.0731 times 2 per 3x over 1 minus 0.3x. Put the x value, you got Cc is equals to 0.0626 mole per decimeter cube. Finish question B. Okay. If you got confused, no problem. Just pause the recording and replay it. Okay. All right. Final question. What is it? Mention that if the reactor were replaced by CSTR, actually till now we didn't find volume of PFR even, but it's fine. Okay, now if the reactor were replaced by CSTR, what would be the required CSTR volume in meter cube? Ensure the unit is correct because here the Ca is in decimeter cube to achieve conversion in part B. Okay, part B, which means the conversion is 0.9 lah. Now, what is the volume of CSTR? What is volume of CSTR if X equals to 0.9? So we just simply use the design equation for CSTR. So volume for CSTR is equals to Fn of X over minus RA. We know that minus RA is equals to KCA cube CB. Okay? So we can simply replace this minus RA with KCA cube CB. So we got volume of CSTR is equals to Fn of X over KCA cube CB. However, okay, Fn naught we know it's 2.5, X is 0.9, yeah, Ca we got already 0.01044 and Cb here 0.0731. We have everything except K. So we cannot solve yet. So we have all information except K. What is K and our temperature? Our temperature is 500 K. However, the question only gives K, which is equals to 0.1 at 400 K, different temperature. EA it give, which is 85 kilojoule per mole. So what do? Based from the equation relating between two temperature and 2K, we have here K2 is equals to K1 exponential E over R times 1 over T1 minus 1 over T2. We have this equation already. We just key in everything. We find out K, which is in this case will be K2, is equals to K1 is 0.1. And then we put the value of E. Just now they mentioned that EA activation energy is 85 kilojoule per mole. So if you plan to put R, the unit is in joule. So you have to put EA, you have to change into joule, 85,000. So R is 8.314. So in your case, please write down the unit as well to ensure that you didn't make any mistake. Temperature is 400, and then another temperature, which is our temperature, is 500. We get K is equals to 16.6. Now we know everything already. So we can find volume of CSTR. So volume of CSTR is equals to Fn naught, which is 2.5 mole per minute, times X, which is 0.9, over K, 16.6, times Ca, which is 0.01044 cube, times Cb, which is 0.0731. We got the value is 1629 meter cube. Ensure the unit is correct. So we have solved our problem. Okay. You can always recheck back your equation whether you have fulfilled answering all the questions. So we have already know how to extract information and translate those information into useful information like this one. We know that, so you have to know how to write chemical formula, how to balance it. Those are basics, so you have to do that. If you didn't balance it, it's actually affect your stoichiometric table, because here it will involve the stoichiometric coefficient. So remember, if you are stuck, just translate all the information into useful new information. So when you translate, see, you find the limiting reactant already, you can rewrite the equation into the correct form where we start with the limiting reactant first, A, and then we translate, say, the reaction equation into the Rate law, because it mentioned elementary reaction. So you can find the Rate law for the limiting reactant. You can also find the Rate law for other reactant and product based on the relative rate of equation. Relative rate equation, okay? So you find the Rate law. So now you have translated every information in the paragraph into useful information. Then only you proceed. You change the chemical equation where you will divide by the stoichiometric constant that the elementary reactant have. So you have this new chemical reactant. This will ease you in tabulating the stoichiometric table. Then you complete the stoichiometric table. This won't be so hard. Find all the constant that you can solve. So you find theta B, find theta C, find delta, then you solve for epsilon. And then don't forget you have another one, since it's a gas, you find the Ca naught. Solve all information, you got your new table, except for X, it become like an equation lah. So you have solved A. Then solve B, where you want to find the concentration itself. You know X, so you simply find Ca, Cb, and Cc. Okay, then the next question, they ask for CSTR. You have to know what is the formula for finding volume of CSTR. You have to relate the K by calculating K for our temperature, which is 500 K, with the K at the temperature given from the equation. Find the K, put into the equation, now you solve the volume of CSTR, okay? That means that you should be able to extract information and modify all equation as required. So I think that's all for now. So we'll meet again on tomorrow in our class. Hopefully you are able to solve another question. So I'll give you another question for you to practice. Okay, everyone, thank you very much. We'll meet again. Assalamualaikum and thank you.